Right, so we're on to the next kind of chapter and the next topic, and we're going to look at the domain and range of functions to start with. Okay, so a function is just anything where we've got f of x. An example would be, say, x squared. That's a function, okay? Every function has a domain and every function has a range. We will get to what those are in a second, but first we will draw f of x equals x squared. Okay, so if we draw this graph, we know that we're going to have a parabola that passes through our origin, so that's kind of like f of x equals x squared. And we've got our x and we have our y-axis. And that's something you should know already from National 5, just what a basic parabola looks like. It should be in our heads without really having to think about it, especially with all our moving of graphs that we've just done as well. Okay, so if we're thinking about the range of a function, right? Range is something we've heard elsewhere. We talk about range when we're looking at statistics and values and graphs and things. Like we talk about the mean, median, mode, and the range. So we've got like a selection of data. The range is the maximum minus the minimum. So it's like the range that it goes over. Sorry, apologies there for using range to describe what range is, right? But for when we're looking at functions as well, this is telling us what values our output can have. So not what values we can put into our function, but what range of values can come out of our function. So if we look at our graph, that's kind of what that is asking is, or what that's telling us, the range is telling us, or the range is, what values can we get on our graph. So if we look at our graph here that we've got, our y equals x squared, you can see the graph is all positive, yeah? That should be at 0, okay? So our values of y are all positive. Like, it's not possible y equals f of x, so the function's values and y are the same thing. We've got no values of y that are negative. Like, they just don't exist. No matter what we do, what number we put into our function, we cannot get a negative number out of our function. So this is kind of talked about in the range of the function. So we can say that the range of this function is that y is greater than or equal to 0. So like no matter what we put in, y has always got to be greater than or equal to 0. Right, okay, so before we move on to think about domains or anything, we'll do another range question. So range is like our output. So if we've got f of x is equal to sine x, right? That graph, we know, starts at 0, goes up to 1, goes back down. Right, so we know that this is 1, and the graph keeps going as well, and it goes into the negatives as well. And then somewhere that's there, should be kind of in line there, is minus 1. So if you think about the range of this function, we know y is never greater than 1, and y is never greater than minus 1. Like, it doesn't matter what value of x we put in, doesn't matter what our input is, our input into this function could be any number at all. We're never going to get a number out that's more than 1 or less than minus 1, like just into sine x on its own. Okay, so we know that y has got to be between negative 1 and 1. So what we do is we say that negative 1 is less than or equal to y, which is less than or equal to 1. Okay, these kind of used to confuse me a little bit, I have to say, writing them like this. But if we start from the y, we can say here y that way we know makes sense as less than or equal to 1, which is true because y's got to be less than 1. Going from here, I know we don't really normally read from right to left, but in this case we kind of are. And we can say that it's greater than or equal to minus 1. So y's got to be greater than or equal to minus 1 or less than or equal to 1. So we're just saying it's between those two values. Right, so that's range. Range is talking about the values of our output of our function. So going on to look at domain, which can be a little bit trickier. Right, okay, so we've looked at the range of functions, and looking at the domain is a wee bit more tricky. The domain is to do with the input values you can put into a function. So certain functions have asymptotes that we know, and there's other rules that we know, like we can't divide by 0, which means that these affect the domain of our function. So like there's certain values that if we put them in to a function, if you put it into your calculator, you would just get like maths error or syntax error, or something would come up and you wouldn't actually be able to kind of put in a value and get out an output. So we're looking for kind of what values do not give us an output. It's easier to say what values don't give us an output rather than what ones do, because there's quite often an infinite number of things that do give us an output, but only one thing that doesn't. Right, so to explain. So if I've got f of x is equal to 1 over x minus 3. Okay, so we're looking at the domain. Right, so the domain, like I said, is to do with our input into our function. So what we're looking for our domain is what value cannot give us an output for this function. Right, so when we have fractions, we know we can't divide by 0. Okay, so what we're looking for is the value of x that gives us the bottom of our fraction being 0. So we want to know kind of x minus 3, what value gives us that to be 0. And this is an easy one, so we solve it. And if x is 3, then the bottom of our function is 0, and the function will not give us an output. Because we're dividing by 0, we can't do that, so we just get maths error. It's like impossible. Okay, so for this, we know that our domain is that x cannot equal 3, because that will not give us an output. Okay? Right, so other more complicated ones. If we have f of x is equal to the square root of x plus 5, this is kind of the other thing that we need to know. Again, looking at the domain of this function, some functions have absolutely no restrictions on their domain at all. Like the functions that we were looking at before, like y equals f of x equals x squared. There's no value of x that you can't put into that function. Like you can put any value of x into that and you'll get an output. But there are some where we've got fractions or square roots. Sometimes we'll have fractions and square roots where we'll have values that just can't be inputted. The kind of graph we've seen so far that has that is the tan graph, and that's got those asymptotes. Those are kind of values where if you put those in you get unknown or error. Right, so thinking about it, what values can't we have under a square root? We can't square root anything that's less than 0. We can square root 0, but we can't square root anything less than 0. So then we know that x plus 5 for this case has got to be greater than or equal to 0. Yeah? So, kind of a little bit of rearranging. We know that x has got to be greater than or equal to minus 5. Because if you put anything even slightly smaller than minus 5 into that, you're going to get the square root of a negative number, which we don't like. It's imaginary numbers, but wait until advanced higher for that. Don't get ahead of yourself. Okay? So the domain is looking at like the values we can't put into our function to get an output. Okay, I'll do one last one before we move on. And it's going to be bind for the two of them. Okay, so we can have f of x equals negative 1 over the square root of 2x plus 3. Right, so we know both that we cannot have 0 on the bottom of our fraction, and we also can't have the square root of anything less than 0. So this means we know that 2x plus 3 has to be greater than 0. Because if we do the square root of 0, we're going to get a 0 on the bottom of our fraction, so that doesn't work either. So we just know we've got to have 2x plus 3 is greater than 0. So that means 2x has got to be greater than minus 3. So x has got to be greater than minus 3 over 2. Okay, so the domain for this function is that x has got to be greater than minus 3 over 2. Okay, so just as a wee reminder before we move on, range is to do with the output of our function, so like looking at the graph, what values of y can we have on our graph, whereas the domain is kind of what values can we put into our graph. So what values won't give us an output, what values like break the maths laws, what values do things that we can't mathematically solve using real numbers. Okay, so hopefully that's cleared up ranges and domains for you, and we're moving on. More work with functions.